Hello everyone and welcome to the experimental video for the ion exchange lab. So this lab is a pretty cool one. It deals with doing titrations and then makes use of an ion exchange column. So I'm going to show you this column here. Which you can see is prepared in a burette. So what I have here is a layer of glass wool. There's sand. Zoom in a bit more so you can see that. And it's filled throughout the entire burette. I'll zoom out a little bit so I can show you this view. So we're going to be working with this. I'll tighten that for a bit. So what we're doing here is we have this column, we have an ion exchange resin here. You'll see in the lab document, you have to prepare this column. So what we've done, what Erin has done, Mrs. French and I, we've created this column by packing the glass wool, sand, and then this bead, and there's obviously a number of them, that are ion exchange resin. So what we can do is charge these ion exchange beads, or the resin, with 3 molar HCl. That's written in the beginning, the preface of prepping this lab. So we can actually have these ion exchange beads which are completely H+ rich, which is really exciting. The point of this experiment is that we are going to, and I'll zoom out and back real quick so I can go through how to prepare this. So you're going to be given a sample of a salt solution, sodium chloride. We have 3 different samples. They're differing in concentration. You'll be making a dilution first to then analyze and run on your ion exchange column. So what we'll do is we'll do a 1 to 10 dilution using a 25 milliliter volumetric pipette. Using the pipette filler. Simply place your pipette in, draw up your solution, 25 to the line, put it in here, bring it to volume with water. You'll notice all of these are labeled with green. So using the 25 milliliter volumetric pipette to take up 25 mils of your sample, to then put it in a 250 milliliter volumetric, which will give us a 1 to 10 dilution. Amazing. Okay? So, once you've transferred your solution, boom, 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 a little cook show in here. So that's what I did here. So I transferred 25 mils. Make sure that you shake your sample. The whole point of this will be defeated as we're trying to find out the concentration of this salt solution using our ion exchange resin. Okay? So, what we do in this lab is a little wacky to show you all. I'm going to have to do some adjusting with the video here, so I'm going to move this back. Okay. Good. Okay. So what I have here is now a 50 milliliter volumetric. So we're going to be doing samples of 50 mils of our dilute solution. So if you think about it, the burette is 50 milliliters, right? We're putting on 50 milliliters of solution that will be run through completely, right? So the idea is when we draw up our solution, which I will do here for when we're getting started, so I'm now using the volumetric for my samples, this transfer beaker, which is also yellow, is going to be for when you're transferring your 50 mils onto the column. You will not be able to put the full 50 mils of the sample in here because obviously I got about 35 mils, which is accounted for of our beads and resin. Of course, there is some empty space in here where it can fill, but there's no way you can put 50 on this. So what we do is we're going to pipette our sample. Remember to have your pipette completely submerged so you won't get air bubbles and your solution shooting up into your flask. So I'm going to take exactly 50 mils and then I'm going to transfer it into my transfer beaker. So we took our main sample, we made a 1 to 10 dilution by adding 25 mils into here, bringing it up to 250. Now I'm taking 50 mils of my sample, which is in here, yellow for the transfer, and I'll be putting it onto this column. Okay? So that's what I'll be doing. I'll be putting it onto this column. When I do this, I'll be catching it into an Erlenmeyer flask, right? So I'm going to want to titrate this solution. So what happens is we put our sodium chloride solution onto the column. So I have NaCl. As my positive cations travel through this ion, they are going to bump off the hydrogens, which I've used my HCl to charge it. So the sodium bumps off hydrogen. I am then collecting a delightful solution that contains H+ ion. So then I'm going to have an acidic solution in here. Okay? So what I'll do, and I'll show you to start. Now I have my column here. It's all set and ready to go. So the trick is, and I'm going to zoom so you can see how this is done. Woo! There we go. Okay. So you can see the line here. Now what I'm going to do is when you first put the solution on, we're going to want to get the level to be about an inch off the top of the surface. Now, as you can see, these go quite slow. Some of them go a little faster, but we always have to make sure that the solution level never goes below the start of our beads. What this will do is it'll basically allow our column to crack, creating air pockets in here. If we don't have this nice homogeneous column, we'll see error in the data because our volumes, it's much nicer to be working with a column that doesn't have air bubbles or cracks because it could eventually stop the flow of your entire column. So you can see here, let me just make sure, okay, great. I have about an inch, and look, oh, I did about a mil height there, so you can use that as a gauge. So now what you're going to do is we're going to, now that we're ready, I'm going to put my Erlenmeyer flask underneath, okay. I have my Erlenmeyer underneath, and I'm going to begin to put my solution onto the column like so. So it was good I had that little buffer room, because what happens was it allows these to splash up, but it still doesn't mess up the column. So I transfer as much of my solution as I can. And we run her through. So we've acidified this. We've had distilled water put on it to get out any extra hydrogen that would be sourced from the hydrochloric acid. And now what we do is we slowly pour on our sample to allow this transfer to happen. Okay, so 50 mils. We're going to have to do this a few times, certainly. And we'll let that run. So as I do this, I'll be transferring my hydrogen ion concentration by the exchange of our sodium and the organic resin. Okay, so I'm going to do this entire run with you, because then I want to show that we have to rinse the column then with some distilled water. Gorgeous. Remember not to let it run dry. So if you're diligent, this can actually go by pretty quick. You just have to watch it. You have to babysit it, because if it messes up, it's messed up and you got to start over. So what we'll be doing, usually we run a number of analyses. We do like 3 determinations, 4. I'm going to be working with each bench and have you run 2 analyses individually, and then we'll pool together our data based on what we find for each sample. So I'll be assigning benches, a sample, A, B, or C. Together we'll work individually, but then come together in the end to check our data. So I'm now pouring on the last of my sample. Terrific. So this is a very important part. We have to quantitatively transfer all of those sodium ions, right? Because if we're trying to find this concentration, I know the volume, I added 50.00 mil. Right? But now I have to rinse my transfer, because you bet there are still some sodium ions on here. I want all of these swapped out. So I'll run this through, rinse it. So I just rinsed it with my squirt bottle here, but the directions say 3 25 milliliter portions. So what I do is just kind of rinse this a whole bunch of times. So you can either measure out the water or just squirt her in. Put about 100 mils in your squirt bottle and use most of it. So that's what I'm going to do. So once I can be assured that all of this is transferred, I can then go on to the titration. So while that goes, I'm going to place this bad boy over here. and I'm going to get my burette set. So I'm just going to go ahead and take my acidic rinses, whatever the heck you want to call this, and I'll use this for when I prep my burette. So, blue and blue, this is my base transfer. We really don't need a lot of base, so please use it sparingly. I'm going to add a little bit more water to this dude. And then I got my burette set. So this I'm showing you one full run as the experimental for this. And I'll run a separate video with data for our virtual section, okay? Gorgeous. Voila. Sear it up there. I'm going to leave it again about an inch or a mil. And then I'll do the titration. So I'm going to go ahead and stop this because that's our sample. All right. I'll place phenolphthalein in as my indicator in the presence of our base. We will see the color change from clear to pink. Okay, so we're just going to do a normal titration as we've done before. Phenolphthalein will turn bright pink. Thank you all so much. This is the experimental video for the Ion Exchange Lab.